This video will be talking about how we can represent or notate a vector notation and their representation. The first and the very basic method is using some scale. Let's say one scale is 1 centimeter will represent 20 Newton. So if I draw a vector whose length is, let's say, 2 centimeter is the length of the vector, then I can say that this vector represent a force of 40 Newton towards right. And again, let's say I draw another vector of, let's say, 5 centimeter length. That is the measured length of the vector. Then this vector represent a force of 100 Newton. 20 is 1 centimeter, so 5 centimeter will be 100 Newton in upward direction. So in this way we can represent vectors by using some scale. Let's say take another scale. In this, 1 centimeter is 10 meter per second. This scale or these vectors will be represented as velocities. If I draw a vector of 3 centimeter length, the magnitude of this vector will be 3 into 10, 30 meter per second towards right. This vector will represent a velocity of 30 meter per second towards right. Or if I draw vector, let's say 0.5 centimeter in length, so I can say this represent nothing but 5 meter per second towards down, along downward direction. So this is the first method by which we can draw vectors or represent vectors. The second method is the direct method. So in this method, what we do, we just draw the direction and straight away put the magnitude on it. Let's say 50 Newton. So this is a force of 50 Newton towards right. And let's say 100 Newton. So this is a force of 100 Newton towards in upward direction. We can use some other vectors also. Let's say this is 10 meter per second. This is a velocity towards right and 10 meter per second. This is a velocity with 5 meter per second towards left. Okay, so we can represent vectors directly by just giving them directions and writing their magnitude nearby it. In this part, the third type of notation we use for representation of vectors is Cartesian system in ijk form. So I cap is a vector of 1 unit magnitude along x-axis. Similarly, j cap is a vector of 1 unit along y-axis, and k cap is a 1 unit vector along z-axis. So what if I have to represent a vector which is towards right of magnitude 5? I can say right direction is the x direction, so this will be 5 I cap. And what if the vector is in upward direction and has a magnitude 3? It will be 3 j cap. What if the magnitude of a vector is, the direction is downward and it has magnitude 2? It will be minus 2 j cap. Let a vector A is represented as ax I cap, ay j cap, and az k cap. Ax will be called x component of vector A. Ay is y component of vector A, and similarly az will be the z component of vector A. So let's start simple with two components. Let's say vector A has only two components, which are x and y, ax plus ay. So we can represent vector like this. These are x and y axis. So it has a magnitude ax I cap. This is the x component. It has a magnitude ax along y direction, and it also have vector in y direction, which is having a magnitude ay. This vector will be called ay. This can be represented here also. along the y-axis. So the vector A will be this. We'll talk more about this in triangle law as well as in magnitude of vectors, but for the time being, A vector is this, and we can find its length as using Pythagoras. Length of vector A is nothing but length of base, which is ax square, and length of perpendicular, which is ay square whole root. Okay, so we can get the vectors as magnitude as this. Similarly, I'll explain more in magnitude of vector, but for the time being, if this is the vector like above vector, we can find its magnitude by using similar calculations. Component x component square plus y component square plus z component square whole root will give me the magnitude of vector A. So these are the representation ways we can represent a vector into.